Okay, this is lesson 5.3, logarithms and their properties. Today we're going to talk about the basic properties of logarithms, and we're going to start with the definition of what a logarithm is. Okay, so the main point I want to get across on this one is this that's in italics, bolded, and underlined, that a logarithm is an exponent. Okay, so in this, they have two examples up here that a to the y power equals x. That's our basic power function, right? And then is equivalent to y equals, they say this one is equivalent to y equals log a of x. Okay, so there's three things in these arguments. There's the base. So the base is the same in both things. The base here on the exponent is a, the log of a, that's the base. The exponent is y. So y is the answer to a logarithm problem. The exponent is the answer to the logarithm problem, and the argument that's called here, argument, you could call it, think of it as the answer, argument, they both start with a, the same thing. So why would we want to use these problems? We'd use these problems to solve things like 5 to the x equals 40. Right, where this exponent is not going to be a nice number. It's not 5 to the second power, it's not 5 to the third power, it's somewhere in between 2 and 3. So what exactly is that? You know, it's hard to figure out without logarithms exactly what it is. So the main thing on this slide is I want you to remember the logarithm is an exponent, and I want you to be able to go back and forth between the exponent form and the log form using these definitions of the base is the same, the answer to a logarithm problem is the exponent, and the argument where that goes in each one. Okay, so we're going to practice a few examples of logarithms. I'm going to start on the left here. Exponential form, 2 to the third power equals 8. Okay, so write that in logarithm form. So this little analysis here, the 2 is the base, the 3 is the exponent, 8 is the argument, 8 is the answer. Okay, so write that in log form. So log the same base, right? 2 is the base, 2 is the base. The argument comes next in the log form. Argument was 8. And then the logs always equal the exponent, so it equals 3. So going back the other way, this is log of 1/2, argument is 16 equals -4. So we write that as a power function. Our base is going to be the same base here. The base is 1/2. The base there is going to be 1/2. Our exponent, the logs always equal the exponent, so our exponent is going to be -4, equals the argument, which is 16. Okay, so the next one, 5 to the first power equals 5. Write that in log form. The base is going to be what? Log base 5. Okay, so what's the argument? The argument is going to be 5. What's the exponent? Well, the exponent is 1 over there, so it's going to be 1. Anything to that, that's 5 to the first power, of course, equals 5. Going back the other way from a log to an exponential form, the base is 3/4. So we're going to start with 3/4. What's our exponent? Our exponent is the answer to the log problem, right? That's the exponent. That's the answer to the log problem, so it's going to be 3/4 to the 0 power. And of course, that always equals 1. That's why the argument is 1 there in that problem. Okay, so we have problems like this on your homework will be like this, where you'll have to be able to go back and forth between the log and the exponent forms. So in this case, we're looking for the argument, right? That's what we're trying to find out, the argument. And we know the base, and we know the exponent. So we'd rewrite this in exponential form. Exponential form would be the argument x equals 4. That's the base. And the answer to the logarithm equals the exponent, so the exponent is going to be 3/2. Okay, so what's 4 to the 3 halves? That's the same as this when it's half on the bottom. That's the same as a square root. The square root of 4 is 2. 2 to the, and then raised to the third power is going to be 8. So that's how they get that answer there. Okay, some practice problems here to go back and forth between exponential and log form. So I want you to just pause the video for a moment, write on these 4 problems on the left, write those as exponential in the exponential form, and the 3 logs on the right, write those in, well, I said it the wrong way. Write the exponentials in log, write the logs in exponential. Okay, pause the video. Okay, so this one, log, same base 2, argument is 16, equals the exponent, which is 4. Next one, log base 3 of the argument 81 equals the exponent, again, which is 4. This is log base 10. The argument is 1,000, and it's going to equal the exponent, which is 3. The last one, log base 4. The argument is 64 equals 3. Okay, so the other side, write in exponent form. Remember this, all these x's are going to be my exponent. Exponent of what base? Okay, so you actually can solve these problems, right? We can solve them for what they have, for what x is going to equal. So 2 to the x equals 4. So obviously x has got to equal 2 because 2 squared equals 4. So I set up some easy problems for you to figure out here. So this one, the exponent is x, the base is 3, so 3 to the x equals 27. Remember, we can write this 27 is 3 to the third power, so that means x has got to equal 3, but you probably knew that already. Same thing on here, so it's 5 to the x. The base is 5, the exponent is x, equals 125, and x equals 3. Okay, so these 3 properties here are very important to recognize when you see this kind of problem. You don't need your calculator to solve it. You can solve those automatically. And these 3 properties of logs, we're going to go over each one of them. The property 1 is true because a to the 0 power equals 1 for any value of a. So why did they say that? Why did they say that? Why does that go with that? Well, if we change this back to the exponential form, okay, our base is going to be a. The exponent is going to be 0. Anything to the 0 power equals 1. So this is just translated back to the exponential form. So anything, if we have a 1 here on our argument, the answer is always going to be 0. Okay, because that's what to make this argument 1, our exponent has to be 0. Okay, so the next one, we have a log, and then the argument is an exponential function there. It's a to the k. And then it says it equals k. So that's a lot of a's and a lot of k's all together. So you have to recognize that these 2 things are the same base. When you see a problem that's got a number, the 2 numbers are the same there, that's your clue that this exponent is going to be the answer. Okay, so why does that work? Okay, so if we translate this into an exponential function, we have the base is a, so we have a. What's our exponent? Our exponent is k, so a to the k equals the argument, and the argument is a to the k. So that's what they meant down here. Property is true since in exponential form, ak equals ak. So what you have to recognize when you see these is that if you have the same bases here, whatever this exponent is, that's going to be the answer. Okay. The last one, we have an exponent function, but the exponent is a log. It's raised to a log power. Okay. So we translate this one. Property 3 is true since it is the exponential form of that. It must be raised to over 10k. So what does that mean? So it means that the base, if I change this to a log function, so it's going to be log. What's my base? My base is a. Okay, what is my argument? My argument is k. And what's my exponent? Well, my exponent is exactly log AK. Okay, so that's when you see these two things. When you see, a power exponential raised to a log, or they have the same base, then you know that's going to be the answer. That argument of that is going to be the answer there. The exponent here is going to be the answer in that case. So next slide, we have a few of these to practice. Okay, so on the left side, you've got a base raised to a log power. So I want you to figure out what the answer is on those. And on the right side, you've got a log, and the argument is an exponential function there, something raised to a power. Okay, so pause the video. You should be able to whip through these in just a few seconds if you understand what I meant on the other video. Okay, so since these have the same base, the answer is going to be 7. Same base, 19. Same base, 4. Same base in the general form is going to equal k, right? They have the same base, they're going to be k. Back on this one, same base. The answer is going to be 18. That's my exponent, right? This base raised to that 18 is going to equal 3 to the 18th. 4 raised to what gives me this answer? So it's going to be 11. 1/3 x. Okay, so when you see these have the same base in them, then you know you can do those without your calculator. You can do those quickly and easily, and it's just a matter of recognizing that's just the same. You understand where we went to on the last slide, how we got there. You'll understand how to do the problems. Okay, solving logarithm equations. Different parts of it we want to solve for x. So usually when they have it in a log form like this, you have to translate it back to an exponential form. So we'll do a first off. Okay, so a, this is the answer to, x is the answer to a logarithm, log of base 8, arguments 4. So that means that that x is going to be an exponent on which base? Base 8. It's going to be raised to the x power, and it's going to equal 4. So these are like our problems we had last section where we had the type 1. We can change these to be the same base, and we could just solve them directly, right? So this is both of base 2. So that 2 to the 3rd is 8. 2 squared is 4. So we get that. We get 3x. The exponents have to be equal. So 3x equals 2. X equals 2/3. Pretty easy there. So 16. The part B. Log of base x. Argument is 16. And the exponent is going to be this 4. That's the exponent. That's the base. Okay, so if we translate that back into a exponential form, x to the 4th equals the argument is 16. Okay, so we can take, to solve this problem, we would take the 4th root of both sides, or maybe even, realize that that is 2 to the 4th power equals 16. It's not too hard. And so mathematically, taking the plus and minus of each side, you get plus or minus 2, but we're not interested in the negative value because the bases always have to be positive. The bases on all these logarithms are always a positive number, so the answer there is going to be 2. Okay, on your calculators, there's 2 logs that are built in. Log of base 10 and log of e. Okay, or a natural log it's called. We'll do that in a second too. But on this one, when you see a log that has no number there, no base, then assume that that's called the common log, and that is log base 10. Okay, so these are just a couple of calculator problems. Stop the video, try these other 2, try all 3 of them. Make sure you get log 12, should get that number. Log of 0.1, log of 3.5. Stop the video, try those on your calculator for a second, see what you get. Okay, you should have matched up these answers on your calculator. And remember that these exponents are going to be negative, right? Negative exponents because these arguments are less than 1. this would be 10 to the 0.1. That means the negative 1 equals 0.1. This is 10 to the negative 0.22 whatever is going to equal 3/5 or 0.6. Okay, so whenever the logs are, whenever the argument is less than 1, between 1 and 0, it has to be at least 0, you're going to get a negative exponent to get that happening. So the log answer is always going to be negative if our argument is less than 1. Okay, so we use that on the chemistry. If you guys are in chemistry, we'll be doing this in a couple of chapters from now. But figuring out the pH of something has to do with the hydronium ion concentration. The hydronium ion concentration is always a very small number, right? This is 10 to the negative 4th. It's always a small number. So our exponents are always going to be negative. So they define the pH as the negative log. Remember, this is base 10. Log of whatever the concentration of that hydronium ion is. And they make it negative here because these concentrations are always less than 1. So the answer to that log is always going to be negative, and we want the pHs to be positive, so we just put that negative back in there. So a couple of pH problems here. pH of a negative log of the hydronium concentration. So if it's 2.5 times 10 to the negative 4th, we put that in our calculator, log of 2.5 times 10 to the negative 4th, and we get negative 3.6, but the negative in front here makes it positive, so the answer is 3.6. So anything less than 7 pH is acidic, anything greater than 7 is alkaline or basic. And remember, the answer to the pH is 7.1. pH is defined as the answer to a log problem. So the answer to a log problem is going to be the exponent. Okay, that's our exponent. Exponent to what? Well, the base is 10. So the way to solve this one, put the negative sign on here. So our exponent is going to be negative. And what are we going to figure out what the hydronium ion is to undo the log, right? Log of base 10 to the negative 7.1 power. Put that in your calculator and you get 7.9 times 10 to the negative 8th. Natural log, base E numbers, written like this. Whenever you see an ln in a problem, they're talking about log with a base E. Okay, so we normally write that with the ln for natural log. And the same properties apply for natural log that they did for the other base 10. Right? If the answer is 1, argument is 1, the exponent's got to be 0. This is log E to the e to the 4th, right? The same base. This doesn't look like E because we'd write it as natural log, but it's the same problems we had before. Same base, exponent's going to be the answer. If we take the answer here of log E to the 8th, an exponential function with raised to a log with the same base is going to equal the answer there. So the same properties apply that we had previously. It doesn't matter what base we use. In this case, we're using base E, and it looks like ln. So you remember that ln is base E on the logarithm. Calculator functions here. The natural log looks like the blue one on your calculator. It looks like in the green box there. Evaluate these two. The first one, just punch it in your calculator. Natural log of 12. Okay, you should get this number approximately. And the second one, ln e to the 10. Okay, so whenever we take the natural log of something to the e power, we're going to get that exponent, right? Because this is log e to the 10th. But we just write ln as log of e. Okay, so that's going to just equal 10. Same properties we had before. Okay, compounding interest problems. We had some of those with E in them on the last section. the amount equals the principal times the e to the RT power. Okay, in this problem, instead of putting in the initial amount and the interest rate and the time and it's getting the amount, we have the amount, we have the initial, we have the interest rate, and we want to figure out how much time it'll take to get to that amount. Okay, so they write it, put the numbers in that they gave us in the problem, divide each side by 1500, and you get a problem that looks like this. Okay, so to figure out what this is, if we want to get rid of this e, we have to use those logarithmic properties. If we take that natural log of both sides of this, we're just going to get on the right side, we're just going to get the exponent here, 0.03t. And on the left side, we're going to get the natural log of 1.5. We can get that number from our calculator. But the thing was to get rid of that e, that exponent, by taking the natural log of both sides. The natural log of any the e power functions is just going to be the exponent. Solve for t in that case, divide both sides by 0.03, and you get about 13.5 years. Okay, do the same thing on the calculator if you wanted to. Put ln, put y1 equals the power function, y2 what we want it to equal, solve for where they intersect, gives you about 13.51 years. The table view, same way. Okay, so a couple different ways to solve those same problems. Okay, we're going to stop the video here because we're going to put this on the next one. We've talked long enough for one. I'll see you answer the questions on the forum. I'll see you guys in class tomorrow.